Hello. Well, welcome back. Episode 2. I am pretty excited. I'm really enjoying this series, even though it's only the second episode, but just so much good stuff to come. All right. So last time when we were kind of looking at some stuff, what we were doing was looking at a very simple example of how to build a service in Go. And the kind of the code sort of perspective on that, well, it looked somewhat like this. It was about as basic as you can get, and in fact, this is probably I don't think you could write less code to create a web server in Go. But what we're going to do in this session is we're going to take this and we're going to start to refactor it a little bit. I want to kind of start bringing in some better patterns and some better practices for structuring your code, because these are going to be really important as we go along with the series. So the first thing is we've got to start looking at these handlers. So we've got HTTP handle func there, and it's kind of all a bit untidy. We're ending up with a lot of code inside of our func main. We're going to have to think about testing at some point, and in a few weeks we'll absolutely be running through that. So how would you test this code other than manually? And then you think, when we add the complexity into there, how are we going to test this code? So we need to start refactoring it. So what's going to be the first step? What's the first thing that we want to do? Well, I think the first thing that we want to do is get all of all of the content of this handle func into an independent object. So let's see how we can do that. All right. So what I like to do is I like to add a package for my handlers. So a package in Go, I'm just going to create a folder. I'm calling it handlers. And then inside of that package, what I'm going to do is add a new file, and let's add a hello.go. Okay, so it's a blank file. Package handlers, so the standard kind of start of a Go file. So what we're going to do is we're going to create a strut. So if you remember back from what we were talking about last week, what we were saying was that this HTTP handle func, what it actually does under the hood is convert the function that you're passing as a parameter into an HTTP handler, and it's registering it with the server. So an HTTP handler, if I can find it in the documentation, is an interface. And it's an interface which has a single method on it. Serve HTTP of response writer and request. So that's exactly the same signature as this. So in order for us to create a handler, all we need to do is create a strut which implements the interface HTTP handler. So let's do that. Okay. So first things first, let's create that strut. So we're going to say type. We're going to call it hello. We don't need to call it hello handler or anything like that, because we're already stating that it's in the package handler. So type hello, type struct, and I've typed that wrong. And we'll just leave it blank for the time being. So we add that interface. So let's add the interface, the method which satisfies the HTTP handler interface. So defining a method on a strut in Go. So we're going to do func. We're doing the name of the type, which is hello. Serve HTTP, which is the signature. First parameter is going to be a HTTP dot response writer, and I'm going to call that RW, and I'm going to call my second parameter, which is a reference to an HTTP dot request. No return parameters. So that signature there is what we need to satisfy the HTTP handler interface. So I can copy my code in. So let's just go ahead and completely copy all of this into here. Now, we can look at a couple of things here. So the first thing is that I'm using a logger here. Now, that in itself is fine, but actually I'm going to want some control over this logging at some point. If I'm using maybe a database in here, I'm going to need to have that as an object. I don't really want to be kind of directly creating concrete objects inside of the handler if possible to avoid it. And the reason for that is, again, when we start looking at testability, we're going to need to be able to replace those things and use some techniques called dependency injection. So don't worry too much about that right now. Like, we'll come back to that. But what I want to do is kind of define that pattern that we're going to use. And I want to show you, how flexible things are if you are familiar with things like dependency injection, specifically in Go. So what I can do is I can define on my handler a field. So I'm going to add, well, I'm just going to call it log, and it is, that's probably a terrible name, let's call it L. And it's of type log.logger. And then what I will do is I will follow the idiomatic principles of creating Go code, and I'm going to define a function called new hello. And new hello is going to take a log.logger, and it's going to return a hello handler as a reference. So I can just quickly fill in those details there. We only got a single parameter, so we can just kind of cheat and get that there like that. Okay. So let me just tidy up these references, these import references here. I will not get onto the rant about how broken tooling in Go is right now since Go mod has come in. I promise you, I won't. It doesn't irritate me in the slightest. And I'm just going to set up those imports. All right. So I've got my new hello handler, and then I've got my serve HTTP handler. So my serve HTTP handler, there's literally nothing different from what there was before. I've just extracted this out into its own strut. Now, the benefit of doing that dependency injection there, so that new hello, which takes the logger, in my test, I can replace logger with something else. I don't have to worry about the concrete implementation. And for logging, I think it's pretty useful. Sometimes you want to log to a file, sometimes to stand it out or something. So it's nice to configure that on a broader level. But when we start getting into connecting to databases and connecting to other services and things like that, we really, really need to be doing dependency injection to be able to write good, fast unit tests. So I'm going to replace that log.print line with just h.l, because L is log.logger and log.logger has a print line method. And then exactly the same way, format.printf. You remember that the response writer implements io.writer. So wherever I can use the io writer interface, I can also use my response writer. So format.printf takes an io writer as a first parameter, and then I can do just my standard kind of format string there, which will write out to serve HTTP. So let's just get this up and running, because I kind of will ignore the second handler for now. So we need to create a reference to the handler. Okay. So we're going to do, well, I'll call it hello handler, and it is handlers.new hello, and that needs a logger. So my logger is going to be log.new. I'm specifying my logger and IO writer. So I mentioned earlier, it's sometimes useful to log to a file. I'm just going to log to os.standardout. So os.standardout. My prefix. This is a nice feature of the logger. So my service here is actually a product API service, or you will see in the coming weeks that it will be. Product API is going to be my prefix. And my flag, it's going to be log dot, I think we've got standard flags or something. There we go. We'll just do the standard flags. I can then inject that with handlers.new hello. So now what I need to do is I need to register that handler with my server. So how am I going to do that? So when I used the function http dot handle func, what is actually happening under the hood there is that we are registering we're converting that function into a handler type, and we are then registering it onto a thing called the default servmux. So the default servmux is a server multiplexer. So it allows you to have multiple handlers, and it contains logic to be able to determine which one to call based on the path. Let's take a quick look at that in the documentation, because I think it's worth looking at. There we go, servmux. So servmux is an object, and it has methods like handle, where you can define that a particular pattern is kind of directed to a particular handler. And again, handle func, so the kind of the package level function I was using is also a function of the servmux object, or servmux type object. Oh, somebody can correct me in the chat, I'm sure. And then so we've got this handler method, and handler allows you, servmux, to return a handler based on an HTTP request. So internally, what is happening is that when a request comes into your server, the server has a default handler. Now that default handler is actually the HTTP servmux. So the server is going to call http.servmux.servedHTTP. Because servmux is also a handler. Okay, I hope I haven't lost anybody yet. But there's special logic inside that serve HTTP in the HTTP servmux, and it determines which of the handlers that are registered against it to call. It then in turn will just call the serve HTTP function of the handler based on whatever the request is, and pass through the response writer and the request. It might be easier if we just look at the code and dig through that. So let's just create it. So what we want to do is we want to create ourselves a new servmux. So it is http.new servmux. Okay. And then on the servmux, we're going to register our handler. So I want just anything, any path. I'm going to register, and I'm going to register that to my hello handler. Now, if you remember when we kind of looked at the basic session last week, again, one of the things that we had was that we said that listen and serve takes two parameters. The first parameter is the bind address. So here I'm binding to everything, every IP address, port 9090. And the second one is the HTTP handler. Now, if you don't specify the HTTP handler, the server is actually going to use the default servmux. I don't want that. I'm going to specify my own servmux that I created, because remember, servmux also implements the handler interface. So let's just see that working, and then we'll dig in. Right. So we can just do go run main.go, and we've got some things to clean up. Okay. I did mention that the tooling is kind of broken at the moment, isn't it? All right, that's running there. So let me just grab a new terminal, and I can curl that endpoint. So curl localhost 9090. I'm going to just pass some data, and I'm just going to say Nick. And it comes back with hello Nick. So everything's working as it was last time, but we've done that little refactor, and we've cleaned up our main logic here, and we've moved everything out into our handler, like so. And that's really nice. And very, very quickly, what we can actually do is we can add that goodbye handler in there as well. So very quick, let's just add goodbye.go package handlers type goodbye struct. It's going to have a logger on there, log.logger. We are going to create that new function. So func new goodbye, pass it a logger, and we're going to return a goodbye handler. So L, right. And then again, we create a handler. A handler has to have a serve HTTP method to sort of adhere to the interface. So it's func, and then it's going to be G for goodbye to add the method. Serve HTTP, again, it's response writer. Oops, response writer is an interface, which is why I'm not using the star there. Request is not. Request is a strut. So you find that there, that's why it's referenced with a star. And quite simply here, what we're going to do is we're just going to write to the output. So I was using format.printf. I can also do things like just write a straightforward byte to that. So by like that. And then again, back over here, what I can do is I can create the new instance of my handler. So I create my goodbye handler, handlers.goodbye, pass it in my logger, and then I'm going to register that with an endpoint, goodbye, and my goodbye handler. So that's cleaned up our code quite substantially, I think. And we can test this. So let's just quit that, and we will obviously fix my pebcac, because if there's nothing I am more proficient at, it is making typing mistakes. And I want to tidy that up as well. If anybody's working with Go and you're very new to it, you probably find that the kind of the tooling is, oh, it works pretty good most of the time. But I think that there's been a very positive shift towards Go modules, which is it's necessary. But in the kind of the interim, some of the tooling that we've used for a long time, such as being able to do automatic imports, some great stuff that like Fatih has written from who created Vimgo, some great stuff that the Visual Studio Code are working on, and sort of Go some wonderful tools for kind of doing IntelliSense type stuff. Well, that's kind of coming under the fold, and you'll kind of start to see that improving over the time. We've now got a Go language server called Go Please, and it's getting there. But yeah, it can be a bit frustrating sometimes. I'm not going to lie. All right, let me just run that again just to prove to you that this is all working. Goodbye, and then we're running bye. Okay, so we've registered those two handlers now. So that's actually cleaned up our code quite substantially, but we're not quite at the pattern that we want to be at yet. And the reason for that is that we've got to start thinking about defaults for things like timeouts. So why is a timeout important? Well, a timeout's important because, think about this. Resources are finite. There's only so many connections that your server can handle at any one time. So if a client connects to the server and starts to do something, and then it just pauses, then that's a blocked connection. So when you get multiples of those blocked connections, ultimately the server then can fail to satisfy the requests. And And it's a kind of a very basic denial of service attack. So really good practice when you're building a service is you kind of just tune those parameters a little bit. So the HTTP listen and serve is going to give us a good sort of basic, but what we actually want to do is we want to kind of dig in a little bit deeper and start looking at the tuning of those elements. And we can do that by manually creating a server. And I do that by creating an HTTP server, like so. So an HTTP server is just a type in Go. So once I've got my server, the server has various properties on it. So let's take a look at that quickly in the documentation. Go documentation at golang.org I think is really, really nice. Go documentation is, I've always been very impressed with what the team do with that, and also the community. I like the kind of the precedents that get set, but very, very nice. So the server, it's got some property fields. We've got the address. We can set our handler. We can set up some TLS configuration. We're going to look at TLS a little bit later in this series, so we'll ignore that for now. But we have things like the read timeout, the maximum amount of time that a server will read from a client. So if a client is uploading a large file, it needs to have a relatively big read timeout. If it's not sending anything really at all, it can have quite a small one. So we can put an element of protection in there. And again, the write timeout. If I'm not writing a great deal of information, a slight tiny little blob of JSON, then I can create quite a small write timeout. If I'm sending a huge file of gigabytes in size, then I potentially want to create a large write timeout. So I'm going to tune these parameters based on the function of my service. And you're probably looking and going, well, what if I've got one handler which only sends a tiny little blob of JSON, and then I've got another handler which sends great big files? Do I have to have one sort of timeout to rule them all? And the answer is, we will come to that in the next session, and we'll look at how you can performance tune that, because it's possible. It's just not as straightforward. Then we have things like the idle timeout. So the idle timeout is all around connection pooling. So there's a kind of TCP connection keep alives, because when a connection is made to your server, making that connection, establishing it, doing the kind of the DNS lookup and the handshakes and things like that, it's not free. It costs time. So if you have a lot of requests from a single client, you can make it more efficient by keeping the connection open. So the client will use the same connection to the server over and over and over again. This is particularly useful for things like when you've got lots of microservices connecting to each other. Now, I kind of want to maintain persistent connections between those, because I want it to be, as I say, to be performant. Especially more important when I'm using TLS, which is a little bit more expensive to establish a connection than just pure TCP. But we're going to kind of tune this as well. If you're making requests, if they're coming from just random clients all of the time, end users, then potentially you would kind of run a low idle timeout. I mean, I think genuinely you probably wouldn't find that you're getting connection keep alives used that often, but again, when you're running service to service, you probably want a higher idle timeout. You want to keep those connections alive. So let's just put those details into our service. So we've got our server. So first things first, we are going to set the address, and we're going to set the address to exactly what we were doing before. I want all IP addresses on port 9090. I'm going to specify the handler, and the handler is going to be my servmux. I'm going to set the idle timeout, and I'm just going to set that to, well, I don't know, 120 seconds. My service doesn't really do anything at the moment. I'll tune that later. 120 second. And then what I want to do is I want to set my read timeout. So my read timeout, I've got a tiny little bit of information here. So I'm going to set this to just 1 second. And then I've got my write timeout. And again, this is really sort of low piece of information. So I'm going to set this. As we kind of run through the kind of the information that I want to teach you in this series of videos, I will look at how you can actually tune these things properly. We're going to look at that when we get into things like observability. But again, for now, I want to set a pattern that we can use time and time again. So then to run that, what I'm going to do is I'm just going to do server.listen and serve. And that'll run there. Okay. So let's just, again, quickly just check that that will run. And we're all good, right? So what's next? We're nearly done with this basic pattern. The only thing that I want to look at next is graceful shutdown. So graceful shutdown's actually really important, because if you're sort of doing something, like if I've got a large file upload, or if I'm doing a database transaction or something like that, and then I just decide that I'm going to shut the server down because I want to upgrade the version of it or something like that. If I don't do it gracefully, then I'm running the risk that I'm just disconnecting my client. They're not allowed to finish the work that they're doing, and it's going to throw an error at them. Whereas with the Go server, what I can do is I can use this shutdown function. Whoops. And what shutdown does is it will wait until the requests that are currently handled by the server have completed. It'll then shut down. So when I immediately call shutdown, the server will no longer accept any more requests. But then it's going to wait until everybody's finished their work. It'll finish, the program will exit, and then we can do our upgrade or whatever without any interruption. Again, the kind of the concept on why this is important may not be 100% obvious to you right now. I think when we start looking at things like reliability patterns and we start looking at some of the techniques around canary deployments and things like that, but we're just going to kind of create a nice base pattern that we can use. So what are the parameters of shutdown? So shutdown takes a context. So what I can do is I can create a context. So I'll call it a timeout context. And it's going to be a context with a deadline. The base is going to just be context.background. And the duration, I'm going to say 30 seconds. So I want you to allow 30 seconds to attempt to gracefully shut down all of the work that's happening. If none of the handlers, if the handlers are still working after those 30 seconds, forcefully close it. So then I can specify shutdown down there with TC. So I'm going to call shutdown with my context, my deadline context. Okay. So this is obviously going to block here in go.serve. So we need to refactor a little. So we're going to put this into a Go func. And we are going to call shutdown. We're going to get the error from that because we're going to be good citizens. And we're going to say if error is not equal to nil, then what we want to do is log.fatal with that error message. But ultimately, that service now will start, and it's not going to block because I've wrapped it up in a Go function. But that means it's going to immediately start to shut down. So what we can do is we can use the OS signal package, and in the OS signal package, we can register for the notification of certain signals. So we can do os.notify. Bear with me. Let's run up to the docs over here. We are going to do OS, and we're going to find notify it's actually os.signal. And here we see you've got notify. So notify takes a channel and a signal. So let's see how that works. So os.notify, and then we're going to specify that channel and the signal. So just quickly looking at that, the channel is of type os.signal. So let's create a channel. So I'm going to create my channel, which I'm going to receive my signal. I'm going to call it sigchan, and it's going to be type chan os.signal. So then I can call os.notify, sigchan, and I'm going to say I want signal.interrupt. So whenever a signal an interrupt signal is received by the system, it's going to send a message on that channel. So I'm going to do signal, and I'm also going to register for kill. So I'm going to do os.kill. So I'm going to trap a forceful kill and also something like Control-C. Okay, so I register those there. And then obviously what I do is I do need to block. So I can just say, I don't know, like sig is sigchan. And then down here, I can just do a log message. I can say log.l. print line received terminate graceful shutdown, or something along those lines. And let me just throw the signal into there. So this is now going to block. So we're pretty much done here. We've just got to do those imports. That's actually signal.notify, not os, Nick. Oh, I moved my stream to my camera. Oh, good Lord. I pushed the wrong button, didn't I? How long ago did I do that? I do apologize. So just backtracking, looking at the code here, I'm handling my listen and serve in a Go func, so it's not going to block. And I have my sigchan, which is going to be signal.notify. So the signal.notify is going to broadcast a message on this channel whenever an operating system kill command or an operating system interrupt is received there. We're obviously going to block here because reading from a channel will block until there's a message available to be consumed. And then once I have consumed my message, then what I do is I'm just going to shut everything down. So we can run that, and OS. I'm just going to manually do the job of my tooling. And I'm going to tidy up my typing mistakes because, there we go. I think that's the last typing mistake. Oh. 45, okay. Context of deadline returns a function as well. I'm not interested in that, so I'm just going to ignore it. Cannot use, okay. What have we got? D time dot, oh, sorry, with timeout. Context of deadline would have been an absolute time. I want to just use a timeout, so 30 seconds elapsed. My typo, right. Okay. So that's now running. We can kind of see here that if I curl, I've got my hello Nick. I can do my goodbye, and we see the bye message there. But now, when I do Control-C, what happens is, you see, I'm getting that received, terminate, graceful, shutdown, and then it's telling me the signal type, which is interrupt. So that's gracefully allowed my application to close any work that's going on in the handler, of which in this example is none, but will close gracefully. So any database connections I might have open, I can close them. Any large uploads that I'm doing, I can finish them, or any communications to another service, I can do that gracefully. I didn't do that without interruption or error to any of my clients. And we've defined quite a nice little pattern there. Very, very simple again, but we're starting to get into a shape where we've really kind of got something that we can start putting into production. Like, all we need now is really some unit tests around our handlers, and we're doing pretty nicely. And that's what we're going to start to look at in a little bit. But next time, what I want to look at is how we can kind of start implementing more RESTful interfaces. So how do I control through HTTP verbs, get, post, etc.? How do I start being able to pass a parameter as part of my URI and to be able to read that? And we're going to look at that. We'll first look at how we can do that with the Go standard library, and then we'll start to look at some frameworks. I'm a big fan of the Gorilla framework, so we'll look at Gorilla framework and see how that makes our lives easier. And that's coming up this weekend. Thank you so much for watching. I apologize about the I pressed the wrong button there and we changed the camera. If that was really bad, when I review the video, I will upload a new video of this again, so you can watch on the review. But thanks so much for watching. Like and subscribe, and I will see you next time. Catch us later.